2017-2018 academic year. My name is Dr. Brett Bennington. I'm the chair of the Department of Geology, Environment, and Sustainability at Hofstra University, and it's my pleasure to introduce our speaker tonight. Before I do that, I just want to make a quick announcement about the talks that we have coming up later in the semester. Just make everybody aware. So on Wednesday, November 1st, 7 p.m. in this room, we have a talk by Dr. Richard Perzer in the School of Engineering on engineering baseball, STEM management, and the national pastime. So all you baseball fans should come to that. On Wednesday, November 29th, 7 p.m. in this room, we have a mechanical engineer, musician, and author named Christine McKinley, who is the author, a recent author of a book called Physics for Rock Stars. And the title of her talk is Physics for Rock Stars, Making the Laws of the Universe Work for You. And then that's it for this semester. And then just to preview next semester, our kickoff talk will be in February, our annual Darwin Day event, and we have Dr. Rob Hill from the School of Medicine who will be talking about evolution and dinosaurs and other really cool things like that near and dear to my heart. So mark that one on your calendar. So it's a great pleasure for me to introduce my good friend and colleague, Dr. Robert Brinkman. Bob, as we all know him, is currently the Vice Provost for Scholarship and Research and the Dean of Graduate Studies at Hofstra University. He's also a professor in my department, Geology, Environment, and Sustainability. He is the founder of our program in Sustainability Studies. Long and prestigious resume. He's the former chair of the board of the National Cave and Karst Research Institute. He's an associate editor for the Journal of Cave and Karst Studies and the editor of the journal called Suburban Sustainability. He's appeared on a number of national news outlets. He's an expert on geologic and environmental issues, particularly issues related to sinkholes and sustainability. He has a blog called On the Brink, which is a very interesting read. I recommend it, which focuses on environmental and sustainability issues. He's written many articles and several books, including Sinkholes of Florida, and his newest book, a textbook, Introduction to Sustainability. And he has two new books coming out in 2018, Case Studies in Suburban Sustainability and Handbook of Environmental Sustainability. So I could go on, but I won't. Let's get him up here. Robert Brinkman to talk about Sinkholes of Doom.
Thanks, Dan. Thanks a bunch. Can I get the, oh wait, click to exit. Let me escape, close this one, and start this one. All right, well, thank you all for having me here. It's great to talk about sinkholes anytime I can. It's one of my favorite topics, but I'm really worried about all of you, I have to tell you. And you might want to think about this in a little bit, why I'm worried about you. I mean, I'm worried about you because back when I first started teaching geomorphology in Florida in 1990, I ran into an interesting phenomenon. Now, geomorphology is the study of landscapes. So when I would teach geomorphology, I would teach landscapes like volcanic landscapes, earthquakes, mountains, rivers, things like that. And whenever I got to the chapter on karst landscapes, sinkholes, caves, and things like that, someone in my class would be impacted by a sinkhole in some way. Their car would fall into a sinkhole. Their mother's condo would be damaged by a sinkhole. Their friends would have a crack in their foundation of their home. Those types of things. Every semester, that would happen to someone in the class. So I'm worried about all of you attending this lecture. Now, the good thing is that Long Island is not Florida. We don't have sinkholes like we see in Florida, but we do have some things like sinkholes, which I'll talk about in a few minutes. But to get us started, let me just give you a little outline of where we're going tonight. First of all, what we're going to learn about is what causes sinkholes to form. Then we'll move on and talk about the ways that sinkholes form. We'll move on to where are some of the sinkholes found around the world and in the United States. Then we'll talk about some well-known sinkholes. I'm sure some of you have heard about some of these that we'll talk about. We'll move on to the detection of sinkholes, how we can find where sinkholes are likely to form. And then we'll move on to the kind of public policy that protects us. So let's kick it off with what causes sinkholes to form. Sinkholes form due to a phenomenon called karst landscape formation. Now, karst is probably the most unusual term in just general geology. It's an unfamiliar term. How many of you have heard of the term karst before tonight? I know a few of you are geologists and have some experience on this, but most of you probably never heard of it. By the end of tonight, you will all be experts in this term karst. Karst is a landscape of soluble rock. It's a landscape where rocks dissolve slowly over time. You might recognize this picture from China, near Guilin, China, where, if you can imagine, the top of those mountains all connected at one time across the land, and over time, the water has worked to dissolve the rocks in between the mountains. So all those places where you see valleys, there were once caves, and where those caves were, those caves collapsed to form the valleys, and those collapsing sinkholes connected together to create this unusual landscape. This is actually a form of karst landscape called cockpit karst. And you see this in places that are very tropical and where there's a great deal of water and some elevation to allow those hills to form. Now, we do have cockpit karst in our hemisphere. We have the cockpit karst in Puerto Rico. We have cockpit karst in Cuba, and we have cockpit karst in Jamaica. Now, we could have cockpit karst in Florida, but something prevents us from having it. What do you think that might be when you think of those other areas? It's the elevation. Florida is a flat, featureless plain with lots of great karst in it, but it is relatively flat, very little room to have space like that. So we don't get the cockpit karst types of formations that we see in the rest of the world. But karst landscapes, what really drives it is limestone or soluble rock of some type. This is an example of what limestone looks like. You've probably all seen it. It's a buff, yellowish rock, sedimentary rock, usually, where you see it as usually you see it in bedding plains. It's pretty easy to identify. Some people can confuse it sometimes with sandstone. On occasion, people can confuse it with shale. But what makes it different from those two kinds of rocks is that it dissolves in water over long, long periods of time. So you often see limestone with unusual weathering features from water formation on the rock. But what is limestone chemically? What is it that allows it to dissolve? Limestone is actually calcium carbonate. So it's made up of two ions, a calcium ion and a carbonate ion, coming together to create a limestone rock. Excuse me. This is actually a mineral. A limestone is a rock, but it's made up of a mineral called calcite. And this is the mineral calcite here. It has a beautiful shape and crystalline structure, fracture structure. It's translucent. It's very soft. You could scratch it easily with a quarter without a problem. You could break it easily if I really wanted to. I could break this without a problem. So it's a very erodible rock, but it also will dissolve in water. Now, this is the mineral calcite, but more commonly we see it forming into things. We see limestone is actually made up of fossils. And I feel like that's moving. Something happened here. It's made up of fossils. Now, this doesn't look like a fossil, but this is actually a core of a giant clam. You know, just a piece of a giant clam that I got as a little piece out of. And it's made up of the same stuff as that mineral sample, the calcite. So most of the shells that you see on the shoreline contain the mineral calcite. And shells, these shells, when they accumulate and turn into rock, will turn into fossils. And with time, these fossils turn into these beautiful rocks, these fossiliferous limestone. This is obviously a cut piece of limestone, but you could see, you could come up afterwards, and you can see all the fossils that are present in this limestone right here to create this rock. Still calcite, still the mineral calcite. It comes in a lot of different forms, and again, it dissolves in water over time. Now, let's talk a little bit about this solution of limestone. You have a couple of interesting things that allow the limestone to dissolve. To understand why it dissolves, we start with air and water. And it's not just any air, it's carbon dioxide plus water creates carbonic acid, and it's the carbonic acid that reacts with the calcium carbonate to create calcium bicarbonate, which goes into solution in water. It's not too different from what I'm going to show you right now. So if we take a little bit of water and if I take some Alka Seltzer, you know what's going to happen. We're turning a solid and turning it into a gas and a liquid. And the solid is disappearing, similar to how the limestone can disappear when it reacts with water. So it takes a longer time, obviously, than Alka Seltzer, but it's the same kind of idea that with time, you end up losing the solid rock and ending up with a void space. So we're going from carbon dioxide in the air plus water to carbonic acid, and the carbonic acid plus the limestone creates calcium bicarbonate. So the limestone plus air plus water equals a liquid, which is weird to think about, that you're turning this to taking this and turning it into a liquid and the ions in solution. Now, what else is interesting about this is if you think about this equation, it has some environmental implications, right? What's driving it is the presence of water. So are you going to see a very active karstic system, a solution system in a desert or in the tropics? The tropics, of course, because there's more water there. But likewise, the carbon dioxide is an interesting thing. The carbon dioxide comes from the soil, from organisms in the soil. One thing most people don't realize about soil air, that air that's in the pore space of soil, is that it's very high in CO2, carbon dioxide, because CO2 is released in the soil by organisms, and you see an abundance of it in soil compared to the atmosphere. So when it rains, that the water helps to drive that carbon dioxide downward into the surface of the Earth. And we have a lot more carbon dioxide under the Earth than we do in the atmosphere, at least on a concentration basis. So if we think about this, where we have a lot of biological activity in the soil, we have a lot of carbon dioxide. So soils that are very, with a lot of life in them are places where we would expect to see more carbon dioxide and thus greater karst activity. Again, we're looking at the tropics compared to the deserts. So what happened to the rock? It's no longer there. We end up with caves, caverns, and void spaces in the subsurface all over the place. Now, these are fascinating things, these caves and caverns that we see across the planet. They have a lot of secondary minerals present. You can see we have stalactites, which hang tight on the ceiling, stalagmites, which might right up to the surface. We have cave columns, cave drapery, all kinds of things like that. And these things are pieces of secondary mineralization of calcite that forms as drip waters containing high amounts of calcium work their way through the caves and can be redeposited in the system, in a cave system. Sometimes you get these beautiful formations that form that look like this with nice shiny deposits on the inside. You could come up and take a look at these after the talk, but they're really quite fantastic, beautiful features. How many of you have been to a cave in your life? Most of you have been. They're wonderful places to visit. We have some fantastic caves here in New York State, some beautiful ones around the country. The longest one in the whole world is here in the United States in Mammoth Cave. We have fantastically beautiful caves in places like Missouri, New Mexico with Carlsbad Caverns, and many others around the US. Sometimes you even get unusual things associated with caves. You can get secondary mineralization. Sometimes you see things like this. This, of course, is a cut piece, but it's the mineral fluorite, which you can sometimes see in caves. And of course, caves have long been home to humans, and you sometimes even see artifacts like this, which is a big spear point, which you can find. This is one's probably about, 6,000 years old. Someone told me this is something like that. These older pieces that you can find sometimes associated with cave systems. Now, not only in karst areas, not only do you get these amazing caves and cave formations, there's also a lot going on in karst systems with water. This is a spring that is found in central Florida in the Ocala National Forest, where the water bubbles out from a cavernous system to the surface to create that beautiful blue water spring. And that spring runs for a little while, and then it disappears back underground into another hole where it re-enters the aquifer system into the cavernous underground. These springs are everywhere in cave and karst areas where you find sinkholes. It's very common. Now, some of you might have even been to this famous spring. Does it look familiar to anyone? A couple of you know. Wachee Springs, which is in Wachee, Florida. And it's a beautiful spring where there have been mermaid shows for years. You can see the water tube there, or the air tube that she uses to breathe. And she's down about 30, 40 feet in a spring with a place where you can view her. You go down the stairs, there's a viewing area. You've been there, so you know what I'm talking about. It's fun to go there. There's a nice show with usually several people swimming to music in the spring. But the thing that they don't really tell you is that spring is emerging from a cavern that is miles long, miles and miles long. And people have been exploring that cave via cave diving and via robots that go into that cavernous system to explore it. And from that, we know how extensive those caves are all underground in Florida. What we know about caves in Florida is that it's like Swiss cheese underground with all of these caverns interconnected almost everywhere. It's stunning. And of course, we know about this fountain, this spring, the Fountain of Youth. Every time I go to Florida, I try to find it. I'm not quite so lucky, but Ponce de Leon, of course, was looking for it right outside of St. Augustine, Florida. Now there's a big tourist attraction near there where you could go visit what people call the original Fountain of Youth. But really, this idea of springs and caves have been very prominent in our cultural landscape for centuries. I remember going to a conference on caves and karst in Rome years ago, and I thought I was going to this major science conference, and it was, but half of the papers were on the history of springs and the history of caves in Italy. And the Roman culture had a lot of discussion about the significance of caves and springs. And even the pre-Roman culture, there's evidence that people used caves for generations. And we'll see later on the significance of caves and the underground water systems to the Maya. Well, this is a photo of people exploring cave underground in Florida. Cave diving is, of course, one of the most dangerous activities you can undertake. Many people have died in caves. It's easy to get lost or to get disoriented in a cavernous diving situation. But some intrepid divers do it. And it's dangerous not only for getting lost, but if you're a geologist, you're probably seeing another reason why it's dangerous. Do you see that? That was once was on the roof at one time. Caves collapse with some regularity. And what happens is that layers after layers of ceilings drop within caves. Next time you visit a cave, take a look at the ceiling of a cave. You'll often see places where there's great cave decoration that's very old, maybe thousands and thousands of years old. And right next to it is this bare, open ceiling without any cave decoration. And that's because that ceiling fell in at some point, and it's starting the formation process over. So a cave often is a multi-generational thing that is migrating upwards through the landscape. It's an interesting thing. So most caves have this incredible rubble breakdown at the bottom of them from the collapse of the ceiling. And you can see where I'm going with that, the collapse of the ceiling, right? Because sinkholes really essentially are just a collapsed cave. That's what they are. Like this one. We'll talk about this one later on, but this is one of the more spectacular examples that we have in the last 50, 60 years or so of a sinkhole forming in Florida from the collapse of a cavernous system underground. So let's move on and talk a little bit how sinkholes form. And I'll try to settle my stomach here a little bit. I planned it out. So first of all, they form in several ways. One way is through the collapse of limestone. And there are other ways that they can form is through a collapse of cover and also through cover subsidence. I know this sounds odd, but I'll explain them all in a diagram coming up. And then the fourth way they form is through anthropogenic formations, which are not at all the same kind of formation, geologic formation I've talked about. But I love to talk about them because they're so important today, and they're so important to the New York region. And we'll talk about those separate. So first of all, the collapse of limestone, that example is right here, where you don't see any kind of cover in the system, and you have limestone that erodes and collapses slowly over time. Now, that is actually one of the more rare types of sinkholes that we see, because almost in all areas we have some kind of cover on top of the rock, right? Otherwise, we would take a shovel and just hit rock right away, and very few of us do that in most parts of the world. There's sediment cover of most types, unless you're in an area on top of a mountain or a place where bedrock is very near the surface. Instead, you have this situation where you have sediment cover on top. Now, in this way where we get cover collapse, the second example is actually the one on the right, and the cover subsidence is the one in the middle. Now, the cover collapse is where there's a cave down here, and then all of a sudden there's a collapse of the whole system to cause these steep-sided features suddenly. There's no warning. Some of these might be very small, this big around, and some might be huge, like the one that you saw the earlier picture of. That was a cover collapse sinkhole. Now, actually, the most common sinkhole, and probably the least dramatic of them all, is this one, which is the cover subsidence sinkhole. Now, what happens with this one is that you have this cave system that has made its way to the surface, near the surface, and that sediment slowly, what we call ravels in, just like sand filtering down through an hourglass. And you've all looked at an hourglass before. You get this dimple on the bottom, on the top of the hourglass that forms, that creates a little depression slowly over time. Now, this one I think is about a 15-minute or 20-minute hourglass, but when we're looking at something like this, this might be, instead of 15-minute, it might be 1,500 years, 15,000 years. Much longer geologically. So you might be living on one of these things and slowly start noticing them over your lifetime. Now, if you built a house on top of one of those, you might not notice a collapse, but one day you might come home and you can't get your door open, or your windows break, and you still get your house a non-habitable notice from the city because it doesn't perform basic services anymore. So you can still have major sinkhole damage from the second kind, or from that last kind of sinkhole. This is an example of what sinkholes look like in nature many times. They're almost unnoticeable. How many of you can see it there? Do you see it? Everybody see the sinkhole? It's right there. You can sort of see it. It continues over to the left a little bit, but that actually is the main area of the sinkhole. Now, what's interesting about sinkholes in a landscape like this is to think about what happens when it rains in a situation like this. Because in most landscapes like we have in New York, in places like Iowa, in places like Louisiana, we get rivers that form and creeks that form, these incredible drainage basins that transport water on rivers. Here, instead, sinkholes serve the role of rivers in the landscape. And if you think that through a little bit, it gets to be kind of complicated, because then all of a sudden you have one point that serves as the drainage point for what can be many square miles worth of water. And how does that water get to that one hole? Well, it can't obviously process that water, so often these karst landscapes are incredibly flood prone because the water can't make it down there all of a sudden. But they're also very droughty as well, because even though it can flood, once that water's down there, it's no longer at the surface. It's in the bedrock underground. So there's not a lot of water storage at the surface in many karst landscapes. Plus, a lot of these sinkholes don't have a single formational incident, like the one we showed you on that slide of that big one in black and white. Instead, this sinkhole can form over long periods of time, and that landscape is slowly evolving, slowly changing over hundreds of years. And if you think about this whole idea of continuous formation, the water issues, these sites are really important for pollution transport, because they're pipes where pollution can enter the groundwater system that can cover hundreds and hundreds of acres. Now, a sinkhole in a rural area is one thing, but in a city, it's another story. This is a sinkhole in a residential neighborhood. There's cars around. People have their pets walking. They take their pets walking by. They're fertilizing that area to make the grass look really green and pretty. Would you want to drink out of a well, now that you know how closely linked the surface is with the underground? Would you want to drink from a well right in that location? I hope not. And in fact, in parts of the city of Tampa, the groundwater is contaminated with E. coli bacteria from pets. So karst areas have really weird pollution issues because of the quick transport of pollutants. Okay, and then of course there's anthropogenic sinkholes. These are the sinkholes that form from the collapse of conduits in cities. And by conduits, I'm talking about things like water pipes, sewer pipes, and other underground infrastructure. Even a subway tunnel could collapse. Now, most of the time, there's very little damage. This was just a headline from just this August where this gentleman's leg fell into a hole in Brooklyn. This is a collapse of a conduit in, again, I think this one is in Brooklyn, where a bus fell in. There have been deaths as a result of these infrastructure sinkholes, and we tend not to pay much attention to them because we could cover them up quickly. But we have really bad aging infrastructure problems in our country due to aging infrastructure. All right, let me go to where sinkholes are found. This is a map of karst landscapes in the United States, or in the world. Karst landscape covers about 20 to 25% of our planet, and there are distinct areas where you would find them. Obviously, the United States has lots of them: Florida, the Appalachian Valley, parts of New York, Pennsylvania, off into the Midwest, big area in Missouri, large areas of Texas. There's not a ton down in South America. There's a lot in the Middle East and North Africa, lots in Europe, Paris, London, parts of Germany, large areas in Russia and Asia, not so much in Australia. Now, if we could focus down a little bit more and look at a karst map of the United States, we can see that focus in a little bit more with Florida. And the darker green areas are the areas where the rock is closest to the surface and where we're most likely to get sinkholes forming. So you can see here in Florida, in parts of the Appalachians, up into New York, parts of Pennsylvania, Missouri, and Texas, New Mexico, Arizona. In fact, I don't have a photo of it, but New Mexico is the only place I know of where there's a sinkhole warning on the roadway because they think part of a roadway in Carlsbad is about to collapse, and they don't know when it will happen. So there it says, sinkhole could collapse at any time. And it's a 55-mile-an-hour roadway. This is a map of reported sinkholes since 1954. I always show this map, but I have to tell you I hate this map. So it's a love-hate relationship I have with this map because it does show you the general distribution of sinkholes in the state here in west central Florida, up here, and all the rest. But what makes me crazy about this map is that it doesn't show you a lot of sinkholes where they could have formed because this is a national forest in here, this is state forest in here. So all of this is prone to sinkholes. Not so many people live up in here. You know, it's a pretty rural area. And there are sinkholes forming there. We just don't get reports of them. Plus, this is one of those maps that's based on self-reporting. A lot of people aren't going to report their sinkholes because it impacts their property values. You don't want anybody to know you got a sinkhole problem, right? You don't. Because try to sell your house after that. So let's talk about some well-known sinkholes, though. I showed you this one first. This was the famous Winter Park sinkhole that formed in 1981. And right over here, this is a big roadway intersection, not too dissimilar from Hempstead Turnpike, you know, same kind of landscape, except they now have a friend, this giant sinkhole, looks like a crater of a moon. And this sinkhole hit a Porsche dealership right in here. And over here was a high school with a swimming pool. You see the swimming pool? And it occurred on the weekend when no one was around, on a Sunday. And so no one was killed or injured in the sinkhole, which is kind of remarkable. but it's one of the more dramatic ones. This is one from Allentown in 1994. It's one of the more interesting ones. The town of Allenton, right downtown Allenton, is in a karst area. It's active. They were very excited to build a brand new office building, and on the day it opened, people were moving in, and they started to hear all these creaks, and they started to realize the building wasn't sound, and they got everybody out, and then this happened. So before anybody could really fully move in and enjoy this beautiful new office building, it collapsed from a sinkhole. I just show one house, but really there are dozens and dozens and dozens of homes that have been lost as a result of a cluster of sinkholes. We call them sinkhole swarms that occurred in west central Florida near Spring Hill back starting several decades ago in Florida, where many, many homes have been destroyed as a result of multiple sinkholes. And part of the problem is really that they built the developments there on a very active sinkhole plain. This is a map of northern Pinellas County. We're very lucky in Florida in that we have air photos that date back to the 1920s, which is pretty rare. And we could compare them with air photos from today and satellite images from today. Let me just point out this piece of land. You see this little piece here is this piece here. So you can see all the development there. So you could kind of match up where people have moved in this general area. What's interesting about this map is that all these little depressions, you see these darker circular features, those are all little karst sinkhole depressions. Some of them are complicated, are interconnected. You can see how complex this drainage system is. And we went through where we could do this kind of mapping. We went through and mapped how many homes were on sinkholes in Florida. And there are thousands and thousands of homes that have been built on these active karst plains where there could be prone to sinkholes. And that's what happened in Spring Hill. They basically developed a karst plain and built houses on top of it. And remember when I said that these sinkholes can form over hundreds, if not thousands of years? They're on an active, very active landscape that is still forming. And well, this might look like a beautiful group of trees. It really is a sinkhole in the middle of a cypress dome. And these cypress domes were largely wiped out as Florida developed for the use of timber. And they were filled in, and houses and developments were put on top of these things so that it could be nice and flat. So today, we see this happening all over the place. So we built those homes, but we now have a thriving sinkhole legal industry in the state of Florida because there are millions of dollars worth of property damage every year. Some of it looks like this. This is a collapsed elevated interstate that collapsed in 2004. And in the city of Tampa, it's called the Crosstown Expressway near downtown Tampa. And it collapsed because of geotechnical investigation did not find a sinkhole as they were building the road. And the roadway collapsed anyways. It's still in litigation after 12, 15 years. This is one of the sadder stories. This is a sinkhole that occurred in Seffner, Florida, not too far from where I have a home, where you can see the sinkhole right here, a very small sinkhole, but it was very deep. And a gentleman was sleeping in his bed, and the sinkhole opened up underneath his bed, and he passed away. They never found the body. And after this happened, another sinkhole opened here that was even larger. So it shows you that sinkholes just don't happen once. They keep happening. It's a progression of landscape formation. This is another very dramatic sinkhole from Florida. This is in the Mulberry area, where a large gypsum stack, which is a mining waste product from phosphate mining, there was a collapse here, and you can see how large it is. You see the helicopter up there. This thing was huge. You can see a large waterfall, and that waterfall is important, as you'll see in a minute. This is what these phosphate processing plants look like. They use a lot of ammonia, they use sulfuric acid, nitric acid. hydrofluoric acid. Tampa has one of the most dangerous ports for hazardous chemicals from everything that goes on there. And the waste product is this thing called phosphogypsum, which is a slightly radioactive gypsum, so it can't be reused because you don't want to be exposed to that little bit of radiation. And on top of that gypsum stack, they put what they call process water, but that process water can contain some of these chemicals, a lot of acids, pollutants, and all the rest. So you can imagine what happens when one of these things collapses into the aquifer. All of that pollution enters the aquifer system where who knows what happens to it. And in fact, the last one that happened that looked something like this, which happened in 2016, wasn't reported to the state for a couple days, or to the public that lived in the area. So a lot of issues, environmental issues associated with sinkholes. Then you might have seen this one. This is the Guatemala City sinkhole that's very famous. I put this up here because this is actually an anthropogenic sinkhole. It's not a karst sinkhole. This one formed from a broken water pipe in an area where there's volcanic ash that's easily transportable. So you ended up with this very deep hole from a water main pipe, and that hole led to the death of dozens of people. And then, of course, as I alluded to earlier, sinkholes are very important for in the Yucatan, because the Yucatan is very much like Florida, except it's higher. So there's more space for caves for people to actually enter into, and there are sinkholes everywhere. In the Yucatan, the ancient Maya had a number of gods of the underworld, gods of water, goddesses of the underworld, goddesses of water, and of caves. And a lot of people did human sacrifices into sinkholes and personal sacrifices, objects of importance to them that they would give up to those gods that lived under there. This is one of the images of one of those gods. So culturally, these sinkholes were really interesting. Well, let's change the topic a little bit. Let's talk about how we can detect sinkholes. Sinkholes can easily be detected by drilling. You just put a pipe in the ground and see if you run into a hole. It's that simple. It's not really rocket science. We're getting that later in the semester. And you could get some of these drill rigs actually in your home if you're worried about a sinkhole in your living rooms. They can go right in and drill right in the middle of your home. But this is another way that we can detect sinkholes. This is a geophysical technique called ground-penetrating radar. I think one day we'll have an app on our phone. I keep waiting for somebody to develop one where we could just walk around and find the sinkholes. But right now, this is what the top-of-the-line technology looks like. You just walk this around, and when you're done, you end up with a readout that looks something like this, where you could see where the surface is. It's Florida, so it's flat. You could find the water table, or you could see sand, and all of a sudden you see, whoop, there's a depression here where you could see that there was some sort of underground collapsed to form a sinkhole. All right, what about public policy? Now, public policy on sinkholes is not very well developed. We have major funding for all of the important hazards in the United States. And we need it. I'm not trying to say we shouldn't have funding in those areas, but we have funding for hurricanes, earthquakes, volcanoes, tsunamis, but there's very little funding for sinkhole research or policy. And there's little testing for real estate to protect people. Before a development comes in, a housing development, there's no required testing. Larger buildings, and we could talk about it offline at some point, there is testing required, and in fact, that's why Trump Tower was never built in Tampa, because the land he owned to build it had a big sinkhole underneath it. But there is one group that focuses on cave and karst research. This is the National Cave and Karst Research Institute, which is a partnership made up of 3 entities: the federal government through the National Park Service, the state of New Mexico through New Mexico Tech University, and the city of Carlsbad Their website there is nicri.org, National Cave and Karst Research Institute. I've been involved with that organization for years. We do a lot of work to try to educate people about caves and karst and the significance of it. We've been to Congress to try to make a case for more funding. We've been to the national research centers and all the rest. This is our mission, trying to promote a better understanding. And you might see that Sinkhole is not in the mission, but we run a Sinkhole conference every 2 years somewhere in the United States to try to get scientists and engineers together to talk about them. So a few concluding thoughts now that we've covered a lot of different things about sinkholes and sinkholes of doom. First of all, will sinkholes happen again in our lifetime? We've seen some pretty awful sinkholes where people have died. We've seen sinkholes where communities have been destroyed. We've seen sinkholes that have had a big cultural impact. And the answer is yes. There's this geologic term called uniformitarianism, where we know that the present is the key to the past. What is happening today has been happening throughout time, and evidence that we see from the past, if the conditions are the same, they'll keep happening on into the future. I have no doubt in your lifetimes you will hear more about sinkholes. And as I said, when I started this lecture, I'm really worried about this for you, that you will have some impact now that I've brought this into your lives, because based on what my students have seen. But what we need to do is to have better understanding of how they form through greater science and testing, greater understanding. Obviously, I think he found the sinkhole in this photo. And so with that, thank you very much. And we have time for questions. If you would step up to the microphones on either side, I'd be glad to take them.
So you mentioned like Disney, you mentioned like there's lots of sinkholes in Florida.
Yeah.
So I'm wondering if like you have a place like Disney World, but like I know like there they build like it's up one story or whatever you'd call it. But how would sinkholes impact a place like that where you have basically the entire thing constructed on in some way?
Yeah, it's a great question. I mean, the reality is all of Orlando is prone to sinkhole formation. So it doesn't matter if Disney was built where it was built or if it was built north of where it was built, it would be impacted in some way by sinkholes. And in fact, we saw about 2 or 3 years ago, there was that large sinkhole that formed underneath a resort complex in the Disney area. It was owned by Disney, where a vacation condo fell in. No one was hurt. There was a smart security guard that started banging on doors to get people out of there when they realized what was happening. But the Disney will be impacted by sinkholes on into the future. All of those lakes that Disney is built around, all of those lakes are sinkhole lakes. And the interesting thing about sinkhole lakes is that they typically form from multiple sinkholes, and they coalesce over time. So I wouldn't be surprised to see even some some existing lakes in Florida in the near future.
Hi, could you talk about sinkholes on Long Island?
Sure. Long Island's geology is different from the karst geology we have in other parts of the world. The geology of Long Island is partially glacial and partially coastal. And a large glacier came and dropped a lot of sediment to cause the high part of the island and the northern part of the island. And then a large glacial delta system created this flatter area that we're in right now with these coalescing fans of sediment meeting. And then, of course, because we're on the Atlantic Ocean, that's all modified by coastal activity on the ocean. So we have a lot of unconsolidated sediment, glacial sediment, underneath our feet here. So we're not prone to the kinds of sinkholes, the karstic sinkholes, but we are prone to the technological, the anthropogenic sinkholes that I mentioned that we see in places like Brooklyn. Now, I've heard of stories where people's cesspools have collapsed, right? You've heard that. That's an example of the kind of sinkholes that we see on Long Island. Water mains collapsing, sewer lines collapsing. Those happen with some regularity, and it's part of this problem with America's aging infrastructure that we really need to address.
Can you say something about things that people do that exacerbate the problems with sinkholes?
Great question. There are a lot of ways that people in karstic areas drive sinkholes to form. One of the most dramatic ways that we had over the last 40 or 50 years occurred in Central Florida during a freeze event. During that time, the strawberry growers of the state were concerned about their crops. And the way that they try to protect strawberries when it freezes is they pump a lot of water out and spray it over the strawberry fields at night. What that does is it coats those strawberry plants with ice, and it somehow, I'm not a botanist, but it somehow, I would think that wouldn't that kill them, but no. It protects them from freezing. But it's a lot of water to do that, and they all do it all at once, all of the growers, because it's a sudden phenomenon. Now imagine what that does to the aquifer as all of a sudden all of this water is pumped out, plus winter's the dry season in Florida, and the aquifer is already low, so the water drops even further, and you have this void spaces that are all of a sudden exposed, and sinkholes can occur quite regularly when you withdraw water. That's a common way it happens. Another way that we see them happening from human activity is by diverting water to areas, and all of a sudden all that weight can lead to sinkhole formation. Another way that I have seen them occurring is from public water supply drawdowns, where all of a sudden a new municipal well is put in somewhere, and sinkholes can start occurring in those areas as the community starts drawing out more water in an area. Of course, any kind of change in flow in an area, modification of existing equilibrium can also influence the subsurface water system, change the plumbing. So, great question. Yeah.
Are there any remote sensing techniques we can use to detect and analyze sinkholes?
Yeah, it's a great question. People have been trying to do this for a long time, trying to use remote sensing to analyze them. One way they've done it is through moisture, because sinkholes are connected to the subsurface, so they're looking for moisture signature, and that's probably been the most successful way.
Very interesting talk.
Oh, thank you.
What about fracking?
Fracking's a great question. Most of you are probably familiar with fracking. Fracking is where there are these micro explosions that occur from pressurized fluids that are put underground to expand and crack the rock. Essentially, they're karstifying the system by creating void space in the rock. Now, often it's done with shale, which is not a limestone type of rock. So in shale, it has different porosity and permeability issues compared to a limestone. The concern people have with fracking in karst areas is that the oil and gas companies are saying that they're going underneath the karst systems into shale, and that it shouldn't have any impact in the karst system. But the challenge is, if it got out into that karst system, karst systems are interconnected over large areas. So if you have, remember I talked about E. coli bacteria? If you have E. coli entering a karst system in a city, the whole city can be prone to that pollution very, very quickly. And that's the concern with fracking, is the pollution can be spread very quickly if it enters an existing karst system. All right. Well, thank you all so very much for coming tonight. For those of you interested, there's some things you can look it up here. Thanks a bunch.